Alright, howdy folks, welcome back. Working on a Yamaha generator. This one's a EF6300iSE, as you can see. Had issues with this. It'll crank, it seems to want to fire each compression stroke. We've got spark. Compression was a tad suspect. I've had the head off, relap valves, everything looks good. This is electronic controlled choke and throttle butterfly. I've had the carby off. We did have a couple of issues with that, just some blockages in the carby, so all of that clean and sorted, no issues. I've now put this panel can come off. Put the control panel just loosely screwed on at the moment. They have a fuel stop solenoid at the bottom here. Gone through that all seems to be working fine. These solenoids only operate to shut the fuel off when you turn the key off. All of that seems good. Suspected old fuel, so we've just bypassed that at the moment, just on a separate bottle. Same issue. So in cranking it, I've just managed to get the thing to run, but I'll show you before we show you exactly what I found. I'll need to go a bit further into it and see if we can resurrect it. But when we're back to the no crank situation, hopefully. Maybe not. Now she runs. So basically every crank it would try to fire, but then it just wouldn't start up and run. What I found, go around to the back here, when I unplugged the generator, I'd then finally, for the first time, managed to get it to start and run. Now I'm not sure if this will be a problem again, but what I found, I thought maybe the generator was loading it up and it just didn't want to fire up. I was getting a bit of a puff of smoke out the exhaust each time, but it seemed very similar to either say a low compression issue or not getting enough fuel. Looking through the carby, I could see the butterfly moving, and the choke butterfly opening and closing as it should. Throttle wide open, so it wasn't over fueling. Now I see I've got the fuel stop off, so I'll just connect that back together, because that certainly didn't seem to be an issue before. We may just carry on and just plug this back in. What I found when I've unplugged these connectors, one of these terminals looked a bit odd. I'm not sure if it'll come through on the video, but that top terminal looked a little burnt. The other side looks fine. Now I believe this is a 240 volt generator. Obviously we're in Australia, 240 volt standard. They make these as a 120/240 for the US market. These are all just 240 on each outlet. So we've got 3 outlets, supposedly each 15 amp. Now, when I found that the first one I unplugged was this one down below, and I thought, oh, green crusties maybe in the connector. It does look a tad crusty across the end. And then when I've unplugged this one, in line with the top pin, we have a pin that appears to be burnt out altogether. Now I'm not sure if I've just fixed something by unplugging it and plugging it back in again. I wouldn't mind just plugging these in now that I've noticed I'd left that fuel stop unplugged. We'll just plug these back in and I'll give it another crank and see if we come back to the no crank. If not, I'll get in, we'll fix up or at least pull this plug apart, see if we can fix that connection. I'm guessing it's probably been a tad loose over time. It's been arcing, eventually burnt itself out. But I believe these are 2 3-phase windings, which basically power the inverter board. Each of these comes into the generator, one here and one more down below here, and they effectively come straight from those windings straight across the unit to here. Now I'm guessing if one side or the other isn't working, maybe doesn't power anything up, and then that doesn't power anything else, obviously. And we've got multiple boards, multiple wiring connectors. There's a charge regulating rectifier regulator down below, and then there's this bridge rectifier, which literally is only used for the fuel stop solenoid, and that's the wiring straight down to the fuel stop. So either way, everything goes into the back of this control panel. Most of the engine harness is here. Everything's connected as it should be, and then the rest is generator controls, start control, etc. So what we'll do, I'm going to plug these two back in, and then we'll give it another crank. We may have now overcome a problem just by unplugging and reconnecting, but this literally didn't look like there was much of the terminal left in there at all. So let's see. We'll plug it back in. If it still runs after this, I think we'll fix this top terminal. Then we'll see if she makes power. So I'll be back in a moment. Okay, so that would have been a split second. We'll just carry on. I've plugged those connectors back in. Now we've got the fuel stop connection connected back as well. It's possible there's still a problem with that fuel stop. So let's see. Now back to the no start. The fire on compression, but that's it. Now let's try something without disconnecting the main three-phase coils. We'll just disconnect this fuel stop, if I can do it one-handed. Alright, so the fuel stop disconnected, at least one lead. You need to disconnect the one. We'll see if we've still got the no crank. No start. Crank no start. Okay, that's great. So, not convinced there's anything to do with the fuel stop. I think what we may have had just now, when it did run with with those three-phase connectors disconnected, it's likely there's quite a big capacitor on this board. I'm guessing that capacitor may have still had enough charge, and or the two other big capacitors down here. In fact, there's one, there's a second one down there, and then we have two more on this second board. It's quite a large inverter unit on this, but 6500 watt, 6300 watt. Sorry, you'd probably expect that. Either way, let's dig this connector apart. We'll see if we can connect it. In fact, I might just disconnect for now. We'll just make sure that by disconnecting these again, we'll reconnect the fuel stop. So those disconnected. Fuel stop reconnected, if I can do it with one hand. Alright, 2 seconds. Okay, so fuel stop reconnected. Let's see whether this will start this time. And the other connectors are still disconnected. Hopefully it should be back to a starting situation, crank run situation. Wish me luck. fantastic. I think we're getting somewhere. Well, I'm going to stop this, possibly pause this, and see if we can carry on. I'm going to take those connectors apart, see if we can repair that connector, and we'll see if we can get some power. Obviously we won't get power out of this without those connected, but I didn't even look to see if the rest of the meter works or not. Definitely we get our meter when we're cranking, but of course we won't see much else. It may or may not operate the low oil light, which I might test separate, but that again may be all required to have the generator end working. So yeah, I'll be back shortly. Okay, so getting a bit further with this, windings wise, it's looking like we might have a bit more of a serious issue. Looking at the 3 coils on the connector, that looks okay. A little bit of crusties in the bottom. We've got some odd readings between 1 to so the bottom 2, roughly 1.2. Between the bottom left and the top, we have roughly 1.7. My meter generally gives about a 0 point of 0.6, so you can deduct that from the total. But from the right hand winding to the top, we're at 2.1, so they're already looking not so great. Getting these connectors out, we've managed to get the one out. Second one of course is burnt, and it's also the other end of this is actually quite melted when we look at it closely. So it's a chicken and egg. It was either very loose and it was arcing, or possibly overloaded. That might mean that the inverter's bad. Unfortunately, being that they're fully sealed, potted in plastic, it's a question mark. Going a little further, on one of these, we've actually got a broken wire, and this will just come straight out altogether. So that's not a good sign. And then looking a bit further inside, hopefully, I'm not sure if it'll come up on the camera, we've got burnt windings. So pretty much puts that one to bed. There's not a lot more we're going to be able to do with this. Down the bottom also, now that my phone is getting low on charge, I'll just flick a torch on. You should be able to see inside here. We've also got burnt windings inside there. So at least half of the coils are no good. The others are showing definite signs of problems. You can see the dark on that side is just the looks like magnets around the outside, but definitely at the top here we've got some issues going on inside. You can just see the coils in there. So yeah, it's possible that it just needs, you know, complete stator assembly. But then again, there's the risk of if the inverter's no good, or either half of the inverter, we're still in for the same situation. Not sure of costs, etc. So we just need to let the customer know and see which way we want to go. Possibly a second-hand unit with a dead engine. We know the engine on this one runs well, but we definitely need the stator assembly. I'm not sure if these have a wire wound rotor. I presume in theory they would have to. They won't be, they'd be brushless, but you know, the rotor may be bad as well. We don't know. It was a second-hand machine, bought cheap, so that's unfortunately where we're at with it. Just quickly, if anyone's interested in the wiring diagram for this, may or may not come through so well, but 6300iSE, 220 volt, 240 volt roughly. It looks as though we have the 2 main windings, 3-phase windings, the same here. We have our stepper motors controlling the choke and the throttle. We have a temp sensor on the cylinder head, just an over temp. Fuel shut-off solenoid, ignition coil, charge coil and trigger, or trigger for the coil, battery, starter. Let me see on my list. We got 18. So oil level, this will be low oil switch. There's the rectifier for the fuel stop solenoid. Oil warning LED. Number 11 here is apparently the speed control, overspeed. Speed limiter assembly. And number 9, which is our overload indicator lamp. Number 8 is the economy full run switch. This one is the charge regulator rectifier unit for basically battery charging. This may or may not be any good. It's difficult to test, but when I did have it running briefly, it didn't seem to be charging the battery. But again, that may be reliant on part of the windings in behind the flywheel. I believe that's how it gets powered. Ignition switch, start switch, stop switch. Number 5 is the hour meter. We have our power outlets. Number 3 here is the power, AC voltage indicator to tell us we're getting power coming out of the outlets. They're just wired in parallel. And then you have the 3 main units of the inverter. This one here is the main fuse. Just there's one fuse on the whole unit. Battery plus up to the key switch, and then we have a couple of diodes in parallel. Presumably, just when everything's switched off, there'll be a backfeed diode, I presume. They are in reverse to the general flow, so they may just be quenching diodes or freewheel diodes. Number 9, I think we may or may not have covered. Overload indicator light. So yeah, there you have it, folks. That's where we're at, and unfortunately it's probably not going to go much further on this one, unless we can get good second-hand parts and or a complete machine that has a dead engine, and then hope for the best. Anyway, thanks for watching, and hopefully we'll be back soon.